Okay, the title of today's notes are The Real Number System. Today's August 8th, 2011. I would suggest drawing this diagram in your notes, and then we'll define the 6 terms. Okay, we'll start with natural numbers. Okay, natural numbers are any counting numbers. The numbers you learned when you were 2 years old. 1, 2, 3, 4, 5, and that goes all the way on to infinity. Okay, that's the most specific number there is in the real number system. And the next one is the whole numbers, which is all the natural numbers, but also 0. So all the counting numbers and 0. 0 is a whole number. Okay, and so we've got the natural numbers and the whole numbers, and as we go out, integers. Integers include all the whole numbers and all the natural numbers, but it also includes their opposites. So 1, 2, 3, 4, and -1, -2, -3, -4. And that goes on all the way to infinity. And 0 does not have a negative number. Common question I get. Okay, and as we go further out, rational numbers. Okay, rational numbers, as you can see by the diagram, includes all integers, whole numbers, and natural numbers, but it also has some other numbers. It can be, the definition of it is that it can be written as A over B, meaning a division problem or a fraction, where A and B are both integers. Okay, B cannot be equal to 0. That would take me a long time to explain why B can't be equal to 0, and we might do that in class if we have time. Again, it includes all integers, but then also terminating decimals and repeating decimals. Any terminating decimal can be written as a fraction, and any repeating decimal can also be written as a fraction. So those are all the rational numbers. Any number that can be written as a fraction. Okay, so the big circle you see is all the rational numbers, and it has some subgroups. And then over on the right you see irrational numbers, which there are no subgroups. That's just all other real numbers, any real number that's not rational. This includes pi and any multiples like 2 pi or 3 pi or 4 pi, any of those. And any decimal that goes on forever without repeating. So if you see a decimal that has ... at the end, that means it goes on forever. And if it doesn't have a bar over it, then it's not a repeating decimal. Other common examples of irrational numbers are square roots of numbers that are not perfect squares. Like the square root of 2. We could put that into a calculator and it would give us an estimate, but it goes on forever and we couldn't get an exact number for the square root of 2, or the square root of 3, or the square root of 5. So if it was, say, the square root of 9, which is equal to 3, then that's just a natural number. But if it's the square root of 10, that's an irrational number because it doesn't have a perfect square. So those are the groups of the real number system. Real numbers then are just all rational and irrational numbers. This is usually where, if I was teaching this in class, kids would now raise their hand and ask, are there fake numbers? Which I wouldn't say they're fake numbers, but there are imaginary numbers that you will learn about probably your sophomore year. So we don't need to go through that. If you want to Google imaginary numbers right now, you can, and you can find out what some imaginary numbers are. Okay, thank you. Hopefully that was short enough. There are your notes. Go through, make sure you have all those definitions and you have that picture. Thank you.